Welcome to the RedChip Virtual Conference.
Again, Tom Steipp, CEO and President of Liquidmetal Technologies, trading under the symbol LQMT on the OTCBB. Tom, we see your slide deck. You may begin when ready.
Hey, thanks, Jim. Hopefully everyone can see the slide deck that's up here. I'll just get rid of the Just minimize this here. Okay. Well, good morning, everyone. My name is Tom Steipp. I'm the President and CEO of Liquidmetal Technologies in Orange County, California. Also here at Liquidmetal is Tony Chung, who is the CFO. Tony's not joining me this morning, but both of us will be available for follow-up questions should you have any. One of the downsides of using the technology that we're using today is that a couple of things in my presentation will not be available. I've got a couple of videos. Those will be available. There are links to those on our website. They're YouTube videos. So need to advance the next slide here. There we go. So that we do have a video which comes from the History Channel. For those of you who are not familiar with Liquidmetal, let me give you a kind of a high-level view of what we do. We are a zirconium-based alloy, which is used for replacing high-strength, high-hardness components which need to be in environments where they're not going to be affected by contamination or other factors. So the technology came out of Caltech about 15 years ago. Professor Bill Johnson at Caltech was the primary driving force behind that. The company went public in 2002, and for about the last 10 years, we've been going through the process of commercializing the alloy for use with customers. So we started out, the company has made millions of parts, predominantly in the areas of consumer electronics. The original business model of the company, from a historical perspective, when it went public in 2002, was that it was very vertically integrated. We did our own IP, we did our own alloy, we built our own injection molding machines, we built our own factories, and on top of that we built our own sales force to sell to customers. So you can imagine for new technologies there are benefits of that in that you control all aspects of the technology and can put the investments where you need to. The downside of that is that it's a pretty capital intensive model. And in fact, in about 2010, the company found itself in a situation where it made great progress in terms of the ability to make parts, but was in a situation where there was significant debt, and that while we were looking at the alternatives, there was significant interest on the part of consumer electronics companies. So in August of 2010, Apple took an exclusive license on the technology for use in consumer electronics. So at this point in time, Apple has an exclusive license which we derive no recurring revenue for in the area of consumer electronics. In addition to the license they have, we work on technology collaboratively with them. So what I'm going to do this morning is talk to you a little bit about the transition from research and technology to actual revenue, and the progress and the steps that the company has made. I've been with the company since August of 2010. I believe we're at a point now where we're on the cusp of being able to convert a very exciting technology with some leading edge technology into the ability to actually ship production parts to customers. So I'll walk through that with you. Again, there is an overview video from the History Channel that gives the casual investor a perspective of how over the years different technologies have been deployed and how they move from kind of the technology state to the useful state. This is just the safe harbor statement, which no presentation would be complete without. Let me talk to you a little bit about why we see so much potential in liquid metal. The vision of the company is to transform the way that world-class companies think about making their products. The first thing I want to say is that liquid metal is a very unique alloy. It is 2.5 times stronger than titanium. It is more corrosion resistant than a lot of things like stainless steel to certain contaminants, and very strong. It's not usable for everything. It does have its limitations. But when you take a look at the world of parts today, what you should think about are machined parts. And the reality is that, whether it's race cars or airplanes or things like glasses, bicycles, we show some of the pieces up here that we have made prototype parts for in the past. There are oftentimes machined parts which in the world we have today require skilled operators, large-scale machines, and oftentimes the amount of time required to machine those parts can be upwards of 45 minutes to well over an hour, requiring multiple setups. So what we look at is working with product designers in leading edge companies who are trying to figure out how to improve their technology, reduce their costs, and provide a unique capability either by virtue of appearance, strength, corrosion resistance, hardness that will allow them to differentiate their individual products. At the end of the presentation there is actually a video that was done by Swatch. I probably will be able to show you at least the video of it. You probably won't hear the audio, but I would encourage those of you who are interested in how we actually take liquid metal and then deploy it in a commercial product to go look up that YouTube video. It'll give you a sense of how one company has bridged the gap from unique technology to shipping product. So this just gives you a sense of what the company's vision is. Again, our focus at this point in time is on working with world-class designers who are taking products that they have in production from a machine perspective and showing them how they can improve the functionality of the part while reducing the cost. The way we do this is to take a look at the unique characteristics of the alloy. So when we go into directors of engineering or CTOs, we talk about the high strength of the product and the relatively low rate. And one of the things about liquid metal is this whole concept of net shape casting. Plastics, when you injection mold a plastic, it fills up the mold, and then when it's ejected, it's exactly the same size as the mold. One of the things that's unique about liquid metal is that you can do that with a metal. Any other metal that I'm aware of, if you heat it up, melt it, and form it in any way, it will shrink as it cools. And it shrinks on a non-uniform basis. So one of the very, very unique things about liquid metal is for the first time, it provides the opportunity to, in a cavity, create a specific, very dimensionally specific shape, heat up an alloy, inject it into that mold, and time after time after time have it be 100% consistent with the other pieces that you've made. If you think about a milling machine as a contrast, there's a diamond bit or some kind of rotating bit that takes off metal, carves it down to a specific shape. And you can imagine that during that process there is wear and tear on the bit. And as the bit wears down, it needs to be changed. If it's not changed with the right amount of regularity, then the dimensional size of the part, which is being made by a computer-controlled milling machine, will actually change. So one of the things that we found out is that this net shape casting capability is a mechanism for people who want very, very precise repeatability on their parts. And then next is corrosion resistance. So for things like a lot of acid, salt water, liquid metal, because of its structure, has the capability of resisting that and providing longer life. So if you take a look at what falls out of that, essentially where we are in the process is that we have started out by looking for relatively small, high-volume machined parts. And our criteria here is if a part is less than 100 grams, more than $100, or if the total number of parts that we do on a single cast is less than 100 grams and more than $100, there's a good chance that we can beat the cost of machining. One of the things that we talk about here, I know everybody who's interested in new technology wants to know, well, how protected are you from the IP standpoint? And I would say that this particular technology is as well protected as any I've ever had experience with. If you were to take a look at the research institutions around the world, whether it's Cambridge in the UK, MIT, Yale, Caltech, Stanford, Tsinghua in China, they all have research going on in bulk metallic glass, which is what liquid metal is. I am not aware of any commercial efforts such as we have going on at Liquid Metal to take that research and turn it into commercially available parts. And I believe that the reason for that is we have a very, very strong patent portfolio that goes along with this. And again, what Apple purchased from us was rights to that IP portfolio, and we continue to work on them. This is public, and we continue to work on them with them on strengthening that. They get exclusive use inside consumer electronics. We have rights to use it outside consumer electronics. So what you see here is a technology that is early on in its stages, has great promise in markets that are very, very large, and has significant protection from an IP perspective. And in fact, we have patents on alloys. We have patents on the processing of the alloys, the making of the machines, and the production and the use of the alloys. So very, very broad protection, which we believe is going to be beneficial for us moving forward. From a business model, I talked about the early days of Liquid Metal and the fact that we were really focused at that point in time on doing vertical integration. The business model at this point in time is flipped almost 180 degrees in that our patent work is done actually in conjunction with Apple. Our alloys are made by a company in the Midwest, public company, Materion, which used to be Brush-Wellman. Our machines are made by one of the world's largest injection molding companies, which is Engel, and we use a contract manufacturer in Colorado, Visser Precision Cast, to make those parts. So one of the things you'll see here are initiatives that we've got, prototype parts that we've shipped with customers, and what you need to understand is that our ability to grow the company rapidly is not dependent upon our capital investment, but rather the control of the IP we have, the patent portfolio we have, and the relationship we have with our customers. As evidenced by the fact that our headquarters is in Orange County, we've got 17 employees. We actually have an 18th employee that is joining next week. So you can see that a small number of very highly skilled, leveraged employees is able to create a very significant footprint in a new technology environment. So let's take a look at how that works. For those of you who may not be familiar with bulk metallic glasses, in their molten state, conventional alloys are amorphous, but when they cool, they get a crystalline structure. So the top half of this page shows what steel or stainless steel or titanium would look like in a cooled state under a microscope, and you can see what we term boundary layers there. So one of the things that's unique is if, for instance, you were to polish that upper structure and you wanted to make it into a mirror, you'd note that it'd be a little bit difficult to polish it because the possibility of chipping off the granular structure so that it's not quite smooth. And in fact, that's one of the benefits. On the bottom, you'll see that in contrast, bulk metallic glasses, liquid metal, looks just like it is in the liquid state, and as a result, it has much stronger strength to weight than most of the alloys that are out there. Again, there are some limitations. I probably won't go over those in great detail, but you should know that for very specific applications, the metallic, the structure, atomic structure between traditional alloys and liquid metals gives it unique metallurgical properties. So if you take a look at the physical properties here, you'll see that we've shown liquid metal on the right-hand side of both of these. One is you get yield strength, so things like magnesium, aluminum, titanium, stainless steel. This is its resistance to bending, and then you get specific strength to weight, so that the relative strength of the alloy versus its weight. And again, very substantive differences between other alloys that are out there. So what we've done is look at specific applications where we can take liquid metal, all its strengths and all its weaknesses, and develop applications where those strengths, generally in the areas of machining titanium or machining stainless steel, you can get a stronger, more resilient part that is actually less expensive, which is a benefit to the customer. So our focus is on using this to replace existing parts. One of the things we try to shy away from when at all possible is making brand new parts for brand new products, because the design cycle there is even longer than we experience with the replacement. A caveat here is that anytime a relatively unknown metal and use it to replace something that's been out there for a while, you will get a long design cycle. We're aware of that. We've told people that. We planned for that. Our financing has reflected that. But if you look at it here, the advantages of injection molded parts over CNC, you'll see less cost to produce, and if you think about what it would be like a floor full of CNC machines that need maybe an hour to make a part with an operator standing in front of them versus an injection molding machine that's pretty much operatorless that puts out a part every couple of minutes. So those are the benefits that we see. Our target industries are listed at the bottom there. We've shipped parts into aerospace, contract electronic manufacturing, and medical products. Again, this is not consumer electronics. Apple has that license and we stay away from it, but our focus at this point in time has been to pick very specific applications in specific markets. So the business model, just to give you a little bit more clarity on that, is lined up here. Instead of we at Liquid Metal doing everything, you can see that Materion actually makes the amorphous alloy in their production facility in Elmore, Ohio. Engel makes the injection molding machines, and the contract manufacturing is done by Visser Precision Cast. So the business model works this way. We spend our time and our engineering know-how working with customers who are looking to replace a part. We help them redesign it, because one of the important things is an injection molded part is not simply an injection mold a machine part, because our goal is to make the smallest part that is structural, has the structural integrity to fit the gap. So it looks like we may be experiencing difficulty. Hopefully that's not the case. I'll try to wrap up here, Jim, so that we get questions. But let me just kind of finish up. The business model point is that we work with customers. We get the orders, the POs. We send them to our contract manufacturer, who buys the injection molding machines, buys the alloys, makes the parts, ships the parts to our customers, invoices the customers. We then collect those and then pay our contract manufacturers. So you can see we get a lot of leverage on the technology without a lot of investment in terms of capital. So just to wrap up here, we believe that it is a very broad-based technology which we are just beginning on. There's strong patent protection for that in the non-consumer electronics space. We believe that the relationships we have now are strong. You'll note that without everything being in place, the individual components are it's difficult to have the value there. So an injection molding machine without the alloy or the patents wouldn't be very particularly valuable. We try to pick our relationships carefully so that there is an interrelationship that encourages all of the partners along the way to invest but be rewarded on that investment. Commercial shipments are underway. We started at the end of last year, really the first quarter of this year, shipping prototype parts. Those prototype parts are out for evaluation. Again, we would expect those to continue over the course of this year. It is a lengthy process, but one of the things that we'll benefit from at the end is that virtually all of the projects we're working on have expected life cycles of somewhere in the neighborhood of 3 to 5 years. So it will start slowly, ramp gradually, but there will be staying power in terms of the revenue we get over time. So just a brief discussion about our corporate structure. You can see the number of shares outstanding. We have done a round of financing over the course of the last couple of months where we raised $15 million. We used the proceeds of that to pay off some notes that we had and had at the time about $10 million in the bank. So we see ourselves, there are some nuances of the financing, but generally speaking, we would expect to be able to fund our operations through the end of next year at the current burn rates. So with that, I would just draw people's attention to YouTube. There is a YouTube video out there for Omega's Seamaster liquid metal watch. I'm just going to let you know that it is available. It won't play on our screen as we see it, but it gives you a sense of the benefit that you can get from a very, very unique metal with capabilities that people haven't seen before, and how when compared or combined with things like ceramics, Swatch exceptional job of creating value. In fact, the Liquid Metal Seamaster watch is sold out. We continue to do work with them on an ongoing basis. So Jim, I think that kind of draws us to the end of the presentation, and I'm happy to field questions at this point in time.
Thank you, Tom, and on behalf of all those listening in RedChip companies, I would like to thank you for taking the time to present today. We will go ahead and jump into Q&A. I believe you touched on this in your presentation, but there is a question here on some of the companies that you're currently working with. One you mentioned was Apple. Can you give examples of some other companies you are working with? I know you gave one just at the end of the presentation, but if you could further elaborate on that, we'd appreciate that.
Sure. And before I comment on the other customers that we're working with, well, for starters, we're at a position with most of these companies where they've not released us to use their name, but we have shipped prototypes in electronics manufacturing, in aerospace, and in medical. But a comment about Apple. We continue to work with Apple, but it is only on the development of intellectual property. Obviously, Apple is is an extraordinary company. There is sometimes a little bit of confusion about the financial benefit that liquid metal might derive from Apple, and I want to make it clear to the listening audience that we don't derive any ongoing revenue from Apple. We got a one-time license. We don't have any royalties. As I've said in the past, our interests are very aligned, but not financially. So I want to make sure that that's clear. The company that I can talk about is Swatch. we're into production with them. They've released videos on it. But in terms of company names, as you know, it takes a while to get their internal PR people to feel comfortable, and until we actually get to the point where that's available, I'm not at liberty to release those.
Thank you, Tom. Next question. I know you just mentioned it just now with aeronautics, but can you possibly give some other markets that you feel liquid metal has a strong potential aside from also consumer electronics to break into?
Yeah, I would say the areas where we have the most potential are in aerospace, because obviously they look for the unique properties of the alloy, and are in many cases, not all cases, but in many cases less sensitive to the cost, and in medical. That medical and aerospace in terms of industries are probably the two we've gotten the most traction. Medical, as you know, does a lot with titanium parts, does a lot with machined stainless steel parts, and we've found a lot of interest in what we can do with liquid metal in terms of injection molding instead of machining. If you go back to the cost associated with putting an operator in front of a large CNC machine to develop relatively small parts that turn out to be pretty expensive, if you can do those in mass, from an injection molding perspective, get a stronger part that's as corrosion resistant, that you can do in 1/10 the time, it turns out that there's a benefit to them and to us, and that's where we've gotten a lot of interest.
Thank you, Tom. Next question here. I know it's hard to put a numerical value on this, but could you give a rough number on the value for your patents you guys currently hold?
Yeah, it would be almost impossible to do that. If you start thinking about the value of the patents is related to the application, and the application that we have is outside consumer electronics and outside of mechanical watches. So within that, the best way I look at it is how many machined parts are there. If you wanted to do a surrogate for that, you might go to an industry and say, how many parts do you have that are less than 100 grams and more than $100? And what's the value of that? Some percentage of that is what we have the opportunity to go replace in the industry. And I should also, the caveat is the technology is stable. We can make and ship commercial parts to customers, but it will be evolving for some number of years. We would expect to see the machine that we've got now replaced by or added to by machines that have upgraded technology, and we would expect to be upgrading our production technology for years to come. So what you see today is the validation of commercial viability. What you will see over the course of the next several years is that base capability added to, so we'll be able to make bigger parts in more unique and varying sizes than we make today. So that limit I gave you is not a long-term limit, it's just kind of a filter we've used on the front end.
Thank you, Tom. Next question. You may have also covered this in the presentation briefly, but can you give us an idea of how much Liquid Metal plans to invest in research and development each year?
Sure. We spend today, just to give you an idea, our run rate of expenses has been running about $400,000 a month, about $1.2 million a quarter. We would expect that the R&D effort, which we have today, which is a percentage of that, will be about flat. We have a small team of very highly skilled folks, been doing this for a long time. We've added a couple of new people to that team to help out, but I would expect our run rate, our burn rate to be maybe go up to $500,000 a month, not much, but in the areas of sales and marketing. So again, where we are is prototypes, parts have been shipped, technology has been validated. We will continue to make investments there and leverage the R&D activities from all of our partners. But our unique focus to grow the business over the course of the next 6 months will be in marketing and sales, and that's where you'll see us make some modest investments, leveraging the activities we've had over the last several months.
Thank you, Tom. Next question here. Has the company generated any revenue thus far?
We generate about $250,000 a quarter. That's from prototype parts. So what we generally do is charge for molds. And remember, when you're machining parts, you just buy an ingot, you machine it, you can make one part relatively inexpensively. In our case, you have to make a mold. We actually do all our molding in a vacuum, so they're special purpose molds, and then we sell parts. So that $250,000, you can kind of back into, how many prototypes go out the door based on that. In general, the cost of our molds runs anywhere from $35,000 to $50,000 for a mold, and then we'll charge for parts that go with that. They then get a sense of, hey, if I was going to make parts, here are parts out of a mold, I can test those. And then we have a cycle of, sometimes an iterative cycle where we will make adjustments for them prior to getting into full production.
Thank you, Tom. Next question here. Are there any important parts of your technology that have not been patented yet?
No. Well, the answer to that is there are no parts of our technology that we are aware of that have not been patented. But as we publicly disclosed, we have over 50 patents already in place, and over the course of the last 18 to 24 months, we've put almost another 20 invention disclosures and patent applications in place. So we continue to make refinements as we understand more about the technology, and with our partners, we put those into the patent portfolio that will allow us all to benefit from that moving forward. So I would continue to expect that patent portfolio to grow and the strength of our overall end-to-end solution to be very strong. That is important because we don't have, as you pointed out, the R&D resources necessary to do leading-edge alloy, to do leading-edge machines, or to perfect manufacturing capabilities. On the other hand, it's very important that we stay in touch with universities and other people who are doing research, and our value proposition to people who are doing point solutions, an alloy or a new way to process on a machine, is that the quickest way for you to get that technology and that innovation to a volume market is to license it to Liquidmetal, and we will put that into the value chain and help you gain revenue for it, help us to gain revenue from it.
Thank you, Tom. I believe that will wrap up the Q&A for today. And again, I'd like to thank you on behalf of all those listening and RedChip companies. Thank you for taking the time to present at the RedChip Small-cap Virtual Conference today.
Okay, great. I appreciate it. Thank you very much.
That was Tom Steipp, CEO and President of Liquidmetal Technologies Inc. They are trading under the symbol LQMT on the OTCBB.
This video is not a recommendation or solicitation to purchase or sell any security, nor does it constitute investment advice. Visit redchip.com for full disclosures on RedChip clients.